Review for 14.1, 14.2. Determining which picture here goes with 3 sine of 2x, we have a cosine type graph, a sine type graph, and a sine because it crosses at the origin. So I'm going to predict the sines go with these two. I see that pi over 4 is half of what pi over 2 is, the normal maximum point of sine. So this guy is b. The half makes the period twice as long. Instead of going to 2 pi, it now goes to 4 pi. So this is c. Here we have cosine. It has a maximum value of 3, which is your amplitude, and the 2 cuts the original period in half. So instead of going out to 2 pi, it is now going out to 1 pi. Graph the equation. Well, to determine the period equals 2 pi divided by b, which is 2 pi divided by 2/3. So we multiply by the reciprocal, and we get 3 pi. The amplitude would be the leading number, 3. The increment is the period divided by 4. So the increment is 3 pi divided by 4. So we say 0, 3 pi divided by 4, 2 times that, so 6 pi divided by 4, 3 times that, so 9 pi divided by 4, and 4 times our increment, which is 12 pi divided by 4. 1, 2, 3, and 4. The cosine graph has a maximum value at 0, then back to 0 at the first critical point, negative a, 0, and then back at its maximum a value. So we'll come to our graph. We'll start up at 3. We'll come down. Our first increment should be 3 pi over 4. 3 pi over 4. That'll be confusing for some. Down to negative 3. And right back up. So we have 3 pi over 3. We have 3 pi over 2. We have 9 pi over 4. And then 3 pi. And that has to match your period. The amplitude is the leading value. The period is 2 pi divided by b. So in this case, the period is pi. The increments, which are important for the graph, is the period divided by 4. So it's pi divided by 4. So on our table, 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. The sine graph is at 0 when x is 0. It's at a maximum value of pi, back to 0. you're down at a negative pi, or negative 3.14, and then back to 0 again. So if this is 1, 2, 3, 3.14, 1, 2, 3, negative pi is going to be down there. We'll start out our graph at 0 because it's sine, at pi over 4, 2 pi over 4, which reduces, 3 pi over 4, and then 4 pi over 4, which reduces to pi. We have our maximum, our 0, our minimum, back to 0. And we curve this nice and smoothly through here, and we should always write our equation. Y equals pi sine of 2x. We can include that over here with y equals 3 cosine of 2/3 x. Your leading term, amplitude, is 1/2. The period is 2 pi divided by 3 pi, which is the b value. The increment is the period divided by 4. So you multiply by the reciprocal and get 2/12, which is 1/6. So we'll have 0, we'll have 1/6, we'll have 2/6, 3/6, and 4/6. Always 1, 2, 3, and 4 times that value to the increment. A cosine graph starts out at the maximum. So a maximum in this case is 1/2. Then down to 0, then a negative 1/2, 0, and back up to its maximum. So if this is 1/4, this would be 2/4 or 1/2. This would be negative 1/2. 1/6, 2/6 gets reduced, 3/6 gets reduced, and 4/6. The cosine graph would start up high and come down, roll your graph through here, and write the equation of your graph. Your period we calculated was 2/3. The amplitude, that's the easy one to find. The amplitude is 2. The period is 2 pi divided by b, which is 2 pi divided by pi in this case, which is 2. The increment is always the period divided by 4. So it's 2 divided by 4, which is 1/2. So we come down to our table. We start with 0. Always start with 0. 1 of the increments, 2 of the increments, 3 halves, and 4 halves. We can reduce them, and we go back to the graph. A sine graph always starts at 0, and then it reaches up at its maximum value, and back to 0, and its minimum value, and back to 0. So our amplitude is 2, so we're going to go up and down 2. Start at 0, climb our way back through here. Here's 1/2, 1, 3 halves, and 2. 2 is the period. It has to match. Those two values have to match. Roll through to make your graph. Try not to make it look like shark teeth. And write your equation, 2 sine pi x. That is page number 1 of practice 14.1, 14.2 worksheet.